Today we're going to look at the second part of the factor market, the notion of combining resources. To this point, we've examined labor primarily and what is the impact of adding an additional laborer on the firm and when should the firm stop hiring labor. This is, of course, an unrealistic analysis, however, because firms can consider other resources than labor and do, and combine them together successfully, but still search for the profit maximizing level of output. So today, that's what we're going to begin our examination of, the combination of resources to maximize profit and to minimize costs. If we're only looking at the addition or subtraction of labor, by definition, this is a short-run analysis, because if we're only changing the number of workers that are being hired, all other factors are being held in fixed supply. And of course, if any one factor or more is fixed, then by definition we are in the short run. So this is a way to approximate some long-run analyses by looking at combining different types of resources together. Generally speaking, when combining different amounts of labor and capital, there are two rules that we want to consider. The first of which is the least cost rule. Another way of thinking about that is a cost minimizing rule. This is not an unfamiliar concept to us. We've seen a similar approach when we've looked at combining goods in consumption, that we want to have the marginal utility per dollar spent on good A to be equivalent to the marginal utility per dollar spent on good B. But of course, instead of consuming goods, right now we are producing goods, and to produce goods we need to hire workers. So what we're looking to do is get the marginal productivity of labor divided by the price of labor to be in ratio to the marginal product of capital divided by the price of capital. And what that means is that your bang for the buck will be equivalent. That is, the very last dollar you spent on one resource will provide the same number of goods as a dollar spent on a different resource. This is a way of balancing out our use of resources efficiently. If this is done correctly, if these are in ratio to one another, then that particular number of goods will be produced the cheapest possible way. This is of limited use, though, because we really only use this rule when we are given a specific number of goods. Say the firm wants to produce 500 goods and wants to know the cheapest way to do it. To answer that specific question, we would have to find the combination of resources that satisfies this equation, that the bang for the buck from labor is equal to the bang for the buck from capital. If this isn't true, if you have a combination of resources that adds up to our 500, say, and the bang for the buck for labor is greater than the bang for the buck for capital, that is, the marginal product of labor divided by the price of labor is more than the same ratio for capital, labor is a better buy. You're getting more units of output per dollar spent on labor than you are getting units of output per dollar spent on capital. So to maintain that 500 units exactly, you should reduce the amount of money that you're spending on capital by hiring less of it, and use those funds to hire more labor because they're providing more bang for the buck. So we can use this ratio here to tell us whether we should hire more labor or more capital if we are trying to be more efficient in our use of resources. When combining resources, the rule that is far greater use to us is the profit maximizing rule. It's very rare that you're going to have a circumstance where a business owner wants to produce a particular number of goods. It's rather contrived. Instead, we know that rational decision makers are going to want to receive the maximum amount of profit that they can get from their venture. And to do this, we're going to use this as our profit maximizing rule of combining resources. And while it looks a little ugly, it's actually rather simple, and we've seen it before already when hiring just labor. We hired labor until the marginal revenue product of labor was equal to the marginal factor cost of labor. That is, you never wanted to hire a worker whose marginal factor cost was greater than the marginal revenue product, because it would cost more to hire that worker than the firm would receive by hiring that worker. So all we're simply doing is doing that for labor and then doing that again for capital. Because if the marginal revenue product equals the marginal factor cost, dividing those will result in 1. And if the marginal revenue product of capital divided by the marginal factor cost of capital is also equal, dividing them by each other will result in 1. So simply put, to profit maximize, find out whatever the price of labor is, that would be the marginal factor cost, assuming we're dealing with a perfectly competitive market, which we generally will be, and find where the marginal revenue product of labor equals that cost, and do the same thing for capital. Find out what the price of capital is in the perfectly competitive capital market, and find the unit of capital whose marginal revenue product is equal to that. So that is the way that we can maximize our profit with this. So what I'd like to do now is turn our attention to a practice problem where we can use both the least cost rule and then ultimately the profit maximizing rule to figure out how to advise a business firm. Here we have a scenario of a firm called Rinkrats, and it's very important for us to take a look at the directions here to get the necessary information. So these data represent the hourly production of workers and machines at Rinkrats, a hockey puck factory. Workers in the hockey puck industry are paid $8 an hour, that's worth noting, while machines cost $12 an hour to rent. Rinkrats has fixed costs equivalent to $40 per hour and can sell all of the pucks it produces at a price of $4 each. So that one paragraph contains a lot of information that will be very useful to us as we begin our analysis. So the first thing that I want to do is take note of the price of labor here, that the hockey workers get paid $8 per hour. And it seems that all the workers are getting paid that. So we can take a look and put at the top just a notation that above labor, we're going to put $8. So we know that each unit of labor costs $8 for Rinkrats to hire. At the same time, we want to be aware that the cost of the machines, that is the cost of capital, is $12 each. So over here, we're going to put $12 for capital. So that will just be a reminder to us of what we are going to use as our marginal factor costs for both labor and for capital. The other thing worth noting, and I'm just going to underline it here, is that the pucks are being produced and sold at a price of $4 each. That'll be useful to us and necessary information, but not for the first part. Let's take a look here at our directions. The owner of Rinkrats is an ardent hockey fan, and her favorite hockey player is Wayne Gretzky, who wore number 99. So she would like to make exactly 99 hockey pucks per hour. Now, that is the key to let us know that we should be using the least cost rule. It's giving us a specific number of goods. So what we have to do then is find all of the combinations that add up to exactly 99 hockey pucks. Unfortunately, there's no simple way to go about doing this. We just have to be sort of methodical about it. So we start over here. If there is zero labor, they have zero output from labor. So that means they could combine zero labor with some amount of capital to produce 99. Except that the highest amount of capital that we have over here is 7 units of capital that produce 84. So that's not a combination that adds to 99, therefore we can't use it. And in fact, nothing combines with 0 units of labor to add to exactly 99. 1 unit of labor produces 10. That means capital would have to produce 89 to equal exactly 99. None of them do, so it can't be any combination that involves 1 unit of labor. 2 units of labor produce 18, however. And if 2 units of labor produce 18, it turns out that 81 units are produced by capital. 18 plus 81 is equal to 99. So this is a combination that adds up to 99. So I want to use a star for both of those. Now, that isn't the only combination, though, that adds up to 99, because if I just keep going down the line, the third worker produces 24, and the 5th unit of capital produces 75. 24 plus 75 equals 99. So we're going to do a different symbol here. We'll do a little rectangle to represent that 3 labor and 5 capital also adds up to 99 goods. 4 units of labor produce 29, which means that we'd be looking for 70 from capital. Doesn't look like any amount of capital produces exactly 70, so we can't use 4 units of labor. 5 units of labor produce 33, and 4 units of capital produce 66. 33 plus 66 is equal to 99, so we're going to make another notation here that 5 units of capital and 5 units of labor and 4 units of capital result in exactly 99. There's no other combinations available because 36 doesn't add up with any of these numbers to equal 99. 38 doesn't add up to any of these numbers either. So we only have 3 combinations. Now, it would be fairly straightforward to go through and eliminate these 3 choices to find out which is the least cost. But imagine that you've got more than 7 workers and 7 units of capital, or many more than 3 combinations that result in exactly 99. That's where the least cost rule would be effective. I would point out that because you have 8 different possibilities of labor inputs from 0 to 7, and 8 different possibilities of capital input also from 0 to 7, that there are 64 combinations of labor and capital that are possible for rink rats. And that's a lot to weed through. So these rules can help us to figure out how to determine the number of capital and the number of labor that we should hire. Let's get back to the question at hand, the least cost rule. So we want to find the best way to make 99 hockey pucks exactly. So our least cost rule is the marginal product of labor divided by the price of labor should be in ratio to the marginal product of capital divided by the price of capital. What we need to do then is to determine the marginal products of both labor and capital. The first worker adds 10 goods. The difference between the first and second worker is 8 goods, 6, 5, 4, 3, and 2. Remembering that marginal product is the additional number of goods from one more worker. So that going from 3 workers to 4 workers is an increase from 24 to 29 goods. That is an increase in 5. That's where we get those marginal products from. We need to do the same thing for capital over on the other side. And we're going to do 21, 18, 15, 12, 9, 6, and 3. And those will be our marginal products from capital for each combination, for each number of capital being employed. So now we can take a look at our 3 combinations, 2 and 6, 3 and 5, and 5 and 4, to figure out which combination is the least cost. We're going to start using the long form method, and then we can demonstrate how our rule, our bang for the buck rule, will speed the process up a little bit. So let's take a look. Let's find out the total cost involved with 2 units of labor and 6 units of capital. Well, 2 units of labor are $8 each, so 2 times 8 is going to be 16, and 6 units of capital times $12 each is 72, and if we add 16 and 72, we get $88. And I'm going to put a little star next to this one to represent our starred combination here. Next one, let's take a look at our rectangle, and our rectangle employs 3 workers and 5 machines. The 3 workers at $8 each equal $24. Our 5 machines at $12 each equal $60. And so when we add those 2 together, that combination to produce exactly 99 hockey pucks costs $84. So it's $4 cheaper than what we had seen. So that's a good thing. Let's take a look then at our last combination of 5 units of labor and 4 units of capital that also add up to exactly 99. We denoted that by a dot. 5 units of labor times 8 per unit is 40, plus 4 units of capital times 12 is 48. And if we add those together, we notice that that is also $88. So we've got our 3 different combinations resulting in $88, $84, and $88 again in variable costs. And so obviously, if we were going to make exactly 99 pucks, the best way to do that would be to use this combination, 3 units of labor and 5 units of capital, because that is going to use the least amount of money to produce those goods. Let's use our least cost rule to demonstrate this. So if we start with our first combination of 2 units of labor and 6 units of capital, we see that the marginal product of labor is 8 divided by the price of labor is 8, and the marginal product of capital is 6 divided by the price of capital is 12. So that means that for $1 spent on labor, you'd get one good. 8 divided by 8 equals 1. For $1 spent on capital, you would get half of a good, because 6 twelfths is 1/2. And so that means that labor is giving you more bang for the buck. So we should try to employ more labor. So let's turn our attention to what we know to be the correct answer. 6 marginal product over a price of $8, and compare that to the 5th unit of capital. It has a marginal product of 9 and a price of 12. And 6/8 is actually equal to 9/12. They're both reduced to 3/4. So we know that that is something that satisfies the least cost rule, and that's good news for us because we know that that's the least cost to make 99 hockey pucks. Let's just say that we disbelieved and went to our third and final combination. What is that? 5 units of labor has a marginal product of 4 and a price of 8, combined with 4 units of capital has a marginal product of 12 divided by a price of 12. And we see here that marginal product of capital divided by the price of capital is 1, so that is a better bang for the buck than over here for labor, where it's $1 would get you 1/2 of a unit. So as suspected and anticipated, our best combination is 3 units of labor and 5 units of capital. Now, while you can do this in the long form to prove this, it's the expectation of the College Board that you can use the least cost rule effectively to determine that the last dollar spent on a unit of labor will result in the same number of goods as the last dollar spent on the unit of capital. So we do want to be well versed with that least cost rule. Let's turn our attention now to profit maximizing. Thankfully, the profit maximizing rule is much more straightforward. Remember that the profit maximizing rule is that the marginal revenue product of labor divided by the marginal factor cost of labor will be equal to 1, and the marginal revenue product of capital divided by the marginal factor cost of capital will also be equal to 1. So let's demonstrate here then that we'll need to calculate our marginal revenue product. It's worth noting that our marginal revenue product is equal to marginal revenue times marginal product. Since we have our marginal product columns here, we need to figure out what our marginal revenue is. This is where we have to read between the lines a little bit. In the directions, it says they can sell all of the pucks it produces at a price of $4 each. That means that they're selling the hockey pucks under conditions of perfect competition, and that the price is equal to the marginal revenue. That we've got Mr. Darp here. So what we're going to do is multiply this marginal revenue, $4, times the marginal product of labor, and then times the marginal product of capital, so we can find their respective marginal revenue products. So what we're simply going to do is 10 times 4 is 40, 8 times 4 is 32, 6 times 4, 24, 5 times 4 is 20, 4 times 4 is 16, 3 times 4 is 12, 2 times 4 is 8. On the other side, 21 times 4 is 84, 18 times 4, 32, 72. 4 times 15 is 60, 4 times 12 is 48, 4 times 9 is 36, 4 times 6 is 24, and 4 times 3 is 12. So we've calculated the marginal revenue products of labor for each unit of labor and the marginal revenue product of each unit of capital. Simply put, all we have to do is find out where the price of labor equals the marginal revenue product of labor, and that takes place here at worker number 7. So we're going to circle that. And the marginal revenue product of capital is equal to the marginal factor cost of capital at capital use number 7, or machine number 7. So we're going to circle that. So to maximize profit, this firm should hire 7 workers and 7 units of capital. The 7 workers will produce 38 goods, the 7 capital will produce 84, and if we add those together, we get that 122 units is the profit maximizing level of output when hiring 7 units of capital and 7 units of labor. We can then figure out what the actual profit is going to be by determining the revenue and determining the costs associated with this production. Let's quickly do that. So if we have 122 hockey pucks being produced, and each of those hockey pucks are being sold for $4 a piece, 122 times 4 is equal to 488. So that's our total revenue. From that, we want to subtract our variable costs and our fixed costs. So our labor costs are going to be, we've got 7 workers times $8 per hour. So that's going to be a cost of 56. And if we subtract those out, that's going to leave us with $432. But we also want to subtract out our capital. 7 times 12 is 84. And 432 minus 84 is 348. That's not our profit though, because we have to recall that our fixed costs are also listed here. So we have to subtract $40 from our remaining revenue, and we'll get a profit of $308 per hour, because these were all hourly units with this. So this firm is doing quite well for itself. It's earning an economic profit while employing the profit maximizing number of labor and the profit maximizing number of capital. I hope you see how these work together and what the importance of combining labor and capital is. And as always, if you have any questions, see me after class or take a look in your textbook. Thank you.